So the idea behind Newton's method is this. In the past, I would ask you to solve something like this. You would then sketch the graph. So when x is small, it wants to do this. And when x is big, it wants to do this. So when x is small, it will have an intercept of negative 13, and it will have a gradient of negative 7. And when it's big, it wants to do a positive quadratic. So you would guess your graph to look something like this. Okay, and then for you to solve this, it's you trying to find out the value of x when the whole thing here equals 0. That's this point here and this point here. You would then use complete the square or the quadratic formula in order to find out these 2 points. But then suppose you get given something like this. How would you go about solving this? So a start would be to sketch the graph here. So sketch this. When x is small, we want to do this. So an intercept of negative 11, and a gradient of negative 4. And when it's big, it wants to do this here. So this is similar to a cubic. So from our section on sketching complicated graphs, you should know how to do this by now. So we're going to guess it to be something like this. It might cross over, it might not cross over. So it might cross over like this, or it might not cross over. We can only guess. Okay, but let's try and find out this point here. So our aim here is to try and find out this point. The idea behind Newton's method is that you don't know this point here. You're trying to search for a value of x, where when you put it into here, this whole thing here equals 0. You don't know this value of x here. So the idea here is to make a guess. Let's say at x0 here. So you would make a guess. Let's say 2. Make a guess of 2, and then you would put the number 2 into this whole thing here, and then into here, and then into here. And then that would give you the coordinates here. So the coordinates here, so you would make a guess, and then that would then take you to up here. So the coordinates here would be 2, whatever whatever here. You would put it into this whole thing here. Okay, and then you would then differentiate this whole thing here. So for example, hang on, let's just zoom into this bit here. Okay, so us zooming into here. So originally this was our function. We were trying to solve when this equals 0. So sketch a graph of this. So that would then give us this bit here. We would then make a guess at x0 here. So this is our guess. Okay, let's guess it to be 2. So then that would then take us to up here. So the coordinates here would be x0, and then we would put this into here, into here. That will then give us y0 here, and then we would then differentiate it. That will then give us a gradient. So now we know a particular point, and we know the gradient at this point here. So we can draw the tangent line here. That will then give us the equation of a straight line. So we would make a guess, and then that would then give us the coordinates at one particular point. We can then work out the gradient at that particular point. That will allow us to draw a straight line. That will allow us to come up with an equation for a straight line. So once you have an equation for a straight line, you can then so like y equals mx plus c. You know the equation for this straight line here. So you can set y to be 0. Set y to be 0, and then work backwards to find out your x. So work backwards to find out this x here. So this could be your new guess. This here would be x1. So for example, hang on. So for example, if you were to make a guess of 2, okay, make a guess of 2. So put 2 into here, put 2 into here, put 2 into here. So this will then take you to the y value of 377. Okay, and then looking at this here, differentiate it. It will then give you this, and then put this into here, put this into here, and then that will then allow you to work out the gradient at this particular point. Now you've got one particular point, which is here, and you know the gradient. Therefore, you should be able to draw a straight line. You should be able to come up with an equation for a straight line. So So you know the gradient here, which is this. So you can put this into here, and then the equation for that straight line would be given as blah blah blah, as will be given as this. Okay. So basically what we've done here is we made a guess at 2, and then from this we worked out the precise coordinates here, and then draw a straight line, and then set y to be, so this straight line here is like y equals mx plus c. Set y to be 0. So basically work backwards to find out your x here. So this would be x1. This here would be x0 here. So this is our new guess. So repeat the process again, and then eventually, repeat the process again. That will then give you the gradient at this point here. Draw the straight line again. Eventually, it will converge it will converge towards your solution. Okay. I would need to give you an example of this, and then you see what I mean. But the idea here is you make a guess. The idea here is you make a guess. That will then take you to here. Come up with an equation. Well, work out the gradient, and then come up with the equation for that straight line, and then set y to be 0 here. That will set y to be 0, and then work backwards to find out your new x here. So that will then take you to here, and then repeat the process, and eventually it will converge to your solution. I need to give you an example, then you see what I mean. Okay.